All right, let's begin. Let's get started. See what we can do today. What kind of chaos we can have. To our Twitch viewers, thanks for hanging out with us this Monday evening. We really appreciate you sticking with us and checking out these videos and these streams as we do them. To our YouTube viewers, thanks for sticking with the series. We really appreciate it. It's definitely been quite a ride. So, without further ado, we are going to get back into where we were trying to do yesterday, the last video. Which was we need to troubleshoot the ADC input and the stepper motor driver output, because it looks like they are conflicting. The lead C driver is conflicting with the ADC input. That's what I was looking for. And now my VS Code install on my machine is acting up as expected. So I wanted to make sure things would work as is, because I'm in my office now. So we could see if we could do, on Breadboard, which is the dev kit, to kind of make sure that we can do this before we get started, or before we make any changes on the schematics. And VS Code wants to be a little baby again. I don't know why it has to break itself every time there's an update. Please stop fixing stuff because you break stuff more than you fix. Stop updating, because there's no reason to update. No reason. If these people break more crap every time they update, it's just not worth it. It's just annoying as all get out. I hate this where it works one day and it stops working because people have to keep touching stuff and putting their hands in the cookie jar and fixing stuff. Stop fixing stuff. None of us care. So annoying. So annoying. So now I got to fight VS Code just so we can test this to see how to solve this problem. So I'm trying to fix VS Code right now. So now I'm trying to figure out why it does not want to work. Of course. Of course. Let me try closing out of this, opening up a different module. It's just getting... All right, come on, code. Why in the world? Oh, please stop. All right. Everything wants to change. Okay. What version do I want to use? 5.4.3. Okay. All right. Let's see if we can get this to do something here. I just want to punch myself in the face. All right. Let's delete the build directory. Probably would be helpful if we go to actually that, so you can actually see the fight. All right. Okay, let's start here. Will you work? I have a feeling it'll be fixed. The problem will get solved just by changing this to ADC unit 1. So, let me see here. Okay, good. It built. So, we need to change it to a different GPIO. So, let's go to the schematic. So, right now it's on unit 2, which has been reportedly to have problems with not only Wi-Fi, but apparently the lead C driver. So, let's go to unit 1, and then let's figure out a channel. Unfortunately, the available GPIOs for unit 1, it would force us to break up one of our like inputs or limits, which is fine. For readability, I like them the way they are, but you know what? I'm not going to sit here and complain about it if we could just solve this problem. So let's say we go to, I mean, these are inputs and only anyway, so either way, it works fine reading an ADC. We could, let's see, 38. GPIO 38 is probably one of the RX TX lines. I don't want to touch that. 39, 32. You know what? We will do GPIO 32. Let me see if it's available on the breadboard. 32. So I've basically got right now just a potentiometer set up as a voltage divider, the wiper, basically just kind of picking down the middle. So we're going to do GPIO 32. All right, so we're going to do ADC unit 1. Probably should make those defined so we can fix them, but that's fine here. And ADC channel 4. So that should be GPIO 32. So what this will do, it should read the voltage, which is fine. We don't care about how perfect it is. So that should read the potentiometer's wiper value on GPIO 32. Let's flash it. All right. And let's monitor. Boop. All right, let's see if we get any kind of change here. All right. So we have change. So it's reading the wiper. Okay. Perfect, perfect, perfect. Oh, okay. So we know we can select that GPIO 32. Now what we're going to need to do is I'm going to open this up in Notepad+, drag it off to the side because I need to incorporate this stuff into oh boy, I don't want to ruin this because this is for that. So, all right, here's what we're going to do. All right, let's go to, that was the temp test. I'm just going to, I want to change that too drastically. I just want to have some testing. I should have thought of this earlier. All right, new. This is just for testing. All right. I know I grabbed the build directory, but I don't care. All right, good. Open this with code. All right, because we are going to chop this poor thing up. Okay, so we have that. We have our So we have everything up there. So we need the lead C driver. Okay. Include driver C.H. Okay. We don't really care about GPIOs. We just want to make sure that this and the ADC can play nice. So let's see here. Let's see. We don't need to really do any of that. Not comparing GPIOs. Okay, here we go. All right, so that should all be in the main. Let's go here. Okay. Let's see, timer 4-bit. Okay, the step pin is, we're going to just keep it on the same pin, 12. Right. So we went on the GPIO 12. Let's see, everything stays the same. We're just going to go ahead and let's just go ahead and yeah, let's just go ahead and do that. PWM duty. So it drives. And what's funny is we should be able to pull the sensor off of the potentiometer and put it onto the output pin to the stepper and actually read that and change it. And so they should be able to work together. So let's see here. Let's go on. Wait, get a little bit faster. See if it peeks its guts out. Oh. All right. Control flash. Monitor. Moment of truth. Okay. Okay, we're reading. Okay. Okay. So now that should be GPIO 12. All right, let's see if I can find it. There it is. 12. All right. Okay, so it's not really doing anything. Let me grab an LED. Oh. Got a resistor. Just grab an LED. I don't care how big it is. It's fine that the ADC is not picking it up. I just assumed it would. That was probably bad. Okay, so it's ground. Wait a minute. So I've got nothing on 12? Oh, PWM duty. No, it should be 50. Okay. GPI on. All right, what in the world? And the LED should be lit up. All right. Oh, okay. Why isn't my LED? All right. Now let's try changing my duty cycle. Okay, this is not good. Does that mean the ADC is interfering with it? Ugh. All right. Tons of fun. I have tons of fun crying tonight. Let's try bringing that down. Oop. Okay. Okay. Curiouser and curiouser. Keep those guys up there. Let's get rid of that. So let's see if that's interrupting with the PWM. Right. Okay, it doesn't like pin 12. Okay, why don't you like pin 12? Let's try pin 14. This deaf board might be a little bit. Okay, why am I not getting PWM output? Oh, this is just so enjoyable. What are you doing here? At 32. Okay, so we got ADC. Cat pegged. Let's see what that does. Okay. So if that's fully pegged, I'm missing. No. Do I need these? Let me just copy and paste this stuff. Just because I don't know. Be something there it's needing and it's not complaining about it. There's a one button does it all. Okay. Okay. I am honestly just like completely baffled here. Back to 12. Utterly completely floored as to what's going on here. Let's choose a completely different pin. Okay, this is just getting insane. Okay, why? What am I missing? Missing. Okay, I am honestly just completely baffled. Right. Let's go to here. Take a look at that. What are we doing here? All right. Let's see, timer. Okay, now we're using 8-bit. 10,000. 10,000 hertz. Slow speed. Timer 0. APB clock. Duty. Yep. Okay. 12. This is getting utterly confusing. Okay. Why? Let's put this down here. Or they shouldn't need it because it should up here, but I am so much more confused now than ever. Okay. I am more confused now than when I started this. What the world is going on here? Why doesn't the LED want to work? Two. All right, voltage. Okay. Yeah, millivolts. Okay. So it's effectively not putting anything out. Duty. What is wrong with you? All right. So what we're going to do then is somewhere basic modules, stepper test. Okay. That should go to here. care what that's doing. That should have a problem. So, step for step. Okay, duty 30%. Let's clean out the build. Build it. Oh, this is driving me insane. Flash. Derp. Flash. Oh. Oh. Build it. That'll shut that up. Flash. All right. Come on. Right. Really now? Fine. Let's just shut that down. Okay, we're getting somewhere. Okay. Let's bring in the ADC then into here. All right. Separate test. Jeez Louise. I'm about ready to punch myself in the face. Paste you here. I don't care. Oh. Yeah. Time to punch myself in the face. Open code. Because in here, this is working. So it must be something to do with the ADC one-shot driver and the lead C driver not wanting to play along nicely. So let's go. All right. Come on. Okay. Let's just slowly start bringing this in. I'm going to build, I'm going to flash, I know I don't have a camera or anything to observe the LED, but Okay, so that's fine. Having the headers are there are okay. And AC channel. Let me go back to 32, channel 5. 5 because we're on unit. All right. Should be in the main. All right. Unit 1. Unit 1. Channel 5. Let's make sure. Oh no, channel 4. That was right. So it was right. Oh, 4. So ADC unit 1, channel 4, which is GPIO 32. All right. Okay, it's working in here. I'm just gonna punch myself in the face one of these days. All right, while don't really care about this. Let's grab this. Here. All right. Okay, so the LED is still lit up. And that is off of 32. Why aren't you doing this? Main. What? Why aren't you doing this jive down here, buddy? Wait a minute. Wait a minute here. All right. I think they're having problems. Use APB clock. Let's see here. Let's see, auto clock. Maybe there's a clock conflict. Let's see what that does. LED comes up. We're not going down here. Okay. Let's change this clock. Upper step. Let's change that. To 0. Don't think we can use 0. No. Let's go to... Okay, this is getting a little bit out of hand. Okay. ESP32. All right. Nothing. Let's try that. So the problem is it's not going down and into the main while loop and reading the ADCs. It's like it's just stopping. It's like, dirt, I'm done. It's like something's conflicting and it's not letting it go down here to the while loop. Let's put that PWM back on 12. Put that back on 12. Now, here's what we're going to do. Is we're going to do something crazy. We're going to change the order that these get initialized. Because then I want to see if it reads the ADCs, but the LEDC driver's not working. Not initialize this. What in the world? Oh, this gets curiouser and curiouser. This gets weirder and weirder and weirder and weirder the more I try to figure out why they're not integrating and playing well together. Entered main task. Code goes down here. Boom, 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 boom. So it should be printing something. It's just. All right, let's see here. All right, let's go here. So it should go through all this and then enter this while loop. Let's clear the build directory and let's. So that's even weirder is because it's not puking its guts out saying that there's a major problem. It's just hanging right there. What? Excuse me? Wait, what? Maybe rebuilding the All right. Okay. Maybe I had to just delete the build directory. Maybe that was my own dummy um goofy all right, that might have been me. You know, sometimes I forget to do that. Okay, it's entering the main process loop. ADC's going up. ADC's going down. Up. Up. Okay. All right, well, that's just slapping me in the face. And all right, we're going to do something crazy. No. All right. Sorry for coughing. I completely didn't think about it. I'm trying to find my cheat code. Notepad is in here. No. It's not there. Here. No. Not here. So I'm trying to find, so I don't have to Google it, is... where did I put it? Oh, just Google it. So we are going to see if we get... Let's see if I can find that, what we're going to do. Come on. Okay, so what we're going to do is come up here. No! I didn't want to copy that crap. All right. Don't need this. On that value, okay. Okay. So we're going to do a map function. So basically, it's like the Arduino map. So down here, we're going to grab, so that, we're going to so gosh, I love the fact that AI figures out what I want to do, but I don't want to 2% and 10%, as we're going to go 0 and 90. So basically, I should be able to use the ADC value and control the brightness of the LED, which would verify two things at once, that the LEDC driver and the ADC driver can coexist. I just had to choose a different ADC pin. I had to take it to unit 1 and not unit 2. Okay. All right. So 0 and 80%. So what is the maximum voltage I can read? 3165. Basically off of this. So we're looking at the voltage value, the voltage converted. Okay. ADC value. Okay. Voltage 142. Okay. That should do is give me a so it should assume that 142 is the lowest, and in other words, 0. All right. Okay. All right. So I know you can't see it because I don't have a camera set up in here. You know what? Hold on. Actually, I can just do this real quick here. Let me set up my phone. Start server. Phone webcam. Let's see if I. Okay. Refresh. Oh, 200.1. I have the wrong address in here. Hold on here. Boom, boom. There we go. Okay. Don't know why it wants to do that, but that's fine. All right. So, breadboard. Don't know why it skips there because of this I know why this potentiometer is just beat up and abused, but so it's not a very clean stepping. There we are. Okay. Okay. So it works. Boom. All right. So that says what I was suspecting, that we had to take the ADC port off of unit 2 because somehow timers and stuff were complaining. Let's see here. Do we make sure reference tick? Let's see if we go back to APB clock. See if that works. Clean, build from scratch. Because sometimes I forget to delete, past builds, and I think sometimes that interferes. Because then it doesn't rebuild some of the object files because it doesn't think they changed. And then when it links all together, I think that's part of the problem. By deleting it, just forces it to rebuild all the objects and all the files that it smooshes together. So we should go. Because if we have to change that to the other clock, I'm perfectly fine with it. Oh, here we are. ADC and PWM is functional. And again, we're only on 4-bit. We go to 8-bit. And 10. We should get a little bit better dynamic. I mean, it doesn't really matter at this point. The main thing was testing all that out and seeing how it would work. I think somehow when I was trying to push everything together in the code, it just did not like it. I was just doing something wrong, or like I said, forgetting to delete the build directory. Definitely a lot smoother now. But it works. Okay. So, what that tells us, make sure we're still reading ADC. Yes, we are. Okay. So, then our next video, we are going to take our lessons learned. You know what? Let's just do that right now. Input 1. All right. No. This way we don't forget to do it. All right. Crap. This stuff. Oop. Move you over here real quick, because what we're going to do is you here. And okay, move this guy out of my way now. Yeah, let's just go and take care of this while we're here. Sounds. Oh, where? All right. So input 1 will now be on IO2, and temp sense now is going to be IO32. Let's make sure that that matches our code. This doesn't have to change. It's still going to be a 12. Let's see, or ADC. Okay, that is going to be channel 4. ADC unit 1. Yes, sir. Okay. All right. So we've kind of got the change made in here in the schematic. That way we didn't forget to do it. So maybe what we'll do in the next video is kind of go through, because we're kind of at a point where we're going to have problems doing full integration and full testing without the revision 2 of the board. So I guess the next video, hopefully be Wednesday, but I don't know. Work's getting busy. Wednesday or Friday, I'm not sure of. Definitely Saturday. But the next stream and video, we will go and we'll kind of review, see if we want to add any more test points, any additional features, and then we'll start pushing changes over to the PCB and get all that worked in. Fortunately, we started to get some of that. The new test points. So changing those two things around, the limit switch input shouldn't be too much of a bear. And the temp sensor input, like I said, won't be too much of a bear. Probably move this capacitor, It'll be a little bit of legwork, but we should be able to accomplish it. If we have to move this capacitor to the bottom of the board, we will. But we'll solve that problem when we get to it. Right now, I'm not gonna chase a ghost over nothing right now. So we'll get that in. We'll see if there's any other test points we want to add, because we do have, some room. We can add some more. We have a little bit of room up here. We have this real estate down here. I mean, a little bit here, but I don't think we're going to need to. So I think this, again, sorry, busy day. That's what we're going to end it. And I thank you for hanging out with me this evening. And hopefully we will see you Wednesday, depending on how work goes. So take care and have a nice evening.